So the last case is the UI. This part I wasn't sure I was going to be able to come up with anything for, but it's getting somewhere. It's a little bit tougher to deal with these sorts of objects with views than it is to deal with things like arrays and dictionaries and numbers, because a view is a very specific type of data, but it actually, I think I sort of stumbled onto something that works fairly well. So first let me just show you something so that if we need to wrap up soon, you can at least say that I showed you a cool animation, or an animation, not a cool animation. So first of all, what are you looking at? A bunch of stuff. Here is an interesting item. This is the screen on this side. So the first thing we're going to do, and as I mentioned before, the screen does have sort of global visibility. So the first thing I'm going to do is get the bounds of the screen, which is going to tell our other views how they should configure their layout. It's sort of a hack that's approximating auto layout. So now our views should have the correct screens. The next thing we do is hit this bang box, which is going to send a message, initialize view, init view, and that's going to go over here. So what's going to happen there? It's going to send this view message to a value box, which is holding the bounds of the screen, and that's going to go into a box that's going to create an inset rectangle with an inset of 200 on each side, and then we're going to add an init specifier or key in front of it, and then that's going to go into this box, templates.view UI view. So it's just a UI view, and then that's going to go to this send add subview. So let's just see what it looks like. Okay, so the view is created, but we don't see anything because the view is white, and so is the screen. So over here, we've got an array of 4 values. That's RGB alpha, goes through a little conversion box, which takes those values and turns them into a UI color, which we then add a key to so that it gets routed properly. And then we add one more key, the set key, which says basically set the background color of this view to this color. And something's funky with the interface here, but there you go. So there's our rectangle. Now let's make it dance. So we've got this object, which is the keyframe animation object. We add an anim route key to it so that it goes to the right inlet on the interior of that object, which I'll show you in a moment. And then into that keyframe animation object, we send these. And these are actually, you can kind of look at and figure out what it's going to do, especially if you've used keyframe animations before. So the key path for the first animation is going to be scale. It's going to go from 0 to 3 on a slightly kind of exponential curve. That 0 is going to wreak havoc with it, so I'm going to get rid of it. Don't know where that came from. And then finally, we're going to tell it the, oh man, I'm just making a mess here. I'll probably just have to rewrite that one. Text parsing is not great. So down here, this is the one you're going to see right now, is rotation around the z-axis. It's going to go from 0 to 6.28 radians, so a complete 360 in 5 seconds, and then I'm going to send it a do message just saying, okay, do it now. And the 0, it's a long story, I guess. Okay. Here's our animate view. Let's check on it. Okay, it's still there. And no. And that's pretty cool. I mean, I don't know anybody that's really interested in seeing a rectangle do a 360, but it's more, there are other things you could do besides rotate a rectangle. If you can do that, there are other things that you should also be able to do. I'm going to try to fix this here so that we can have 2 animations at once. So I'm just basically sending an array of arrays to the animation box. So key path, transform.scale. So that's the first component of the animation, followed by the values. And we'll go 0, 1. We'll kind of do that curve again. And if you've used keyframe animations before, you'll recognize these are values that you have to specify if you're doing it in Xcode. We'll give it 5 seconds. Tell it to do right away. Okay. Now, what we should get is, while the rectangle is rotating, it should also expand. Check and make sure it's still there. Okay. So that's fine. Now you can set up a keyframe animation to repeat itself, but let's take a slightly different approach here. So this is an object that gets used in pure data quite a bit. The metro object, which is metro as in metronome, a regular pulse, sends out a bang at regular intervals. So we'll create a metro object that sends out a bang at 5-second intervals. So what we should get is a looped animation. So I send the output of the metro to this animate view, and I need to send a 1 into the hot inlet of the metronome in order to kick things off. So yeah, again, not that many people want to look at a spinning rectangle that's also coming toward them, but there are other things you could do with it. Now I'm thinking I should probably start wrapping up, since I also want to be able to answer your questions. There's quite a bit more stuff that that I didn't get to, but that's fine. I mean, eventually it's going to be released, or it'll be in beta, and you can check it out more extensively then. But I guess one thing that I do want to point out, I just want to show you how this view object works, because it's, I think, kind of gives you a good insight into the overall direction of the project. So this, as much as it might seem like it's completely different from what already exists, or that it's kind of a reinvention of the wheel in a sense, when you look at the internals here, you'll see that it's actually just a different way of interacting with the existing Cocoa libraries. So, for example, here you see lib.util.factory $1. So the $1 is a substitution argument, it's a creation argument that tells this object what kind of view to create. And so here I specified it as a UI view, but I could specify an image view, a text view, a label, anything that is a subclass of UI view. I could give that as a creation argument, and when I send it that init message, that's what I'll get back. Now, you can interact with that view in a lot of really useful ways from within this box. So this is an external, but I guess you could kind of think of it as a wrapper for a UI view. So there are a lot of inlets, which is why I added the additional level of abstraction. But what you have is you can set the view, which also means that this box is not tied to the lifetime of any particular view. It holds one view pointer, or one pointer to a view. But if that view is released or it gets a different view, then that's the end of its relationship with that pointer. While it has that pointer, it can get properties, it can set properties, it can call selectors, add subviews, and do animations. You can extract the layer, the CA layer, from the view, and then you can work with it in much the same way using a layer object, which has the same outlets and inlets. It's just slightly different to deal with the more prevalent usage of C structs in the layer than in the view. Is that all I wanted to say about this? It might be. Yeah, so this is I don't know where exactly I got the idea for this way of working with an object in a data flow format. I think it's just because I didn't know what else to do, because views are very different from the other data types that we've been looking at. But I think that this solution works pretty well because we have single pointer associated with a single box. You can spawn new views, so you're not limited to what you have when you within the box itself. You can add views, you can keep adding them. Things get a little difficult when you start needing a reference to those views that are no longer being held by a view object. At that point, in order to change that view, you would have to access it through its super view, which is the screen. And the screen is the closest thing to a singleton that at least that you'll see right now. And the reason for that is because if you look at these sends and receives, none of them have the $0 specifier. That means they're global. So any object anywhere in this project can send and receive messages from this instance of the screen. And there's only one. There could be more, but there's not in this case. So to give you an example of how you can handle views after they're released by their containers, here's a little patch that clears the subviews. in the screen. So what happens is when it gets this clear screen message, it sends subviews to the get inlet of the screen, which is just another view object basically. And it sends it down, routes it via the subviews key to this object, which crashes it apparently. That was the first one. So I'll put that view back. Oops. Okay, so now I can show you the clear screen, hopefully. So I send that bang, and our view is now disappeared. So what happened? Well, if I can open this without crashing, I can show you. Otherwise, it'll just have to remain a mystery. No. Apparently, it's going to be a mystery. Maybe not. So it's pretty simple. It takes the array of subviews from the screen, puts it through the array drip, which serializes the array into single views. Once that array has been serialized, we send each view to a view box, an external, followed by a remove from superview selector. And that has the effect of enumerating the entire array of superviews or subviews and removing them. And at some point I'm going to have to do something more sophisticated for managing views that you no longer have a reference to. If for no other reason then it's probably going to be needed for auto layout, collision behavior, and that sort of thing. But there's a way to do it. I just, haven't gotten there yet. So I'll leave it there.